This is Math 3 5.4 notes. That's Math 3, Unit 5, Lesson 4. The title is Normal Distribution and Z-Scores, and that's what we're going to be going over today. It says at the top, make sure you fill that in. One special type of distribution of data is called a normal distribution, or the normal model. The normal model is often thought of as the bell curve. A bell curve happens when the data is unimodal, which means it's a single peak. It's not multiple peaks. And the distribution on each side of the peak is symmetrical. On the right half is symmetrical to the left half. Symmetrical. When a distribution of data is deemed to fit a normal model, the blank blank, that standard deviation, is used to break up the normal model into defined sections. The sections are represented below. Okay, what we're about to do to this graph is very important, and I suggest you follow with me, and that is something you're going to have memorized. Okay, plus or minus 1 standard deviation is 68%. So we're going to go on to the right one and left one standard deviation. So that's 1 standard deviation, that's -1 standard deviation. So going to write it like this. This is 1 standard deviation. This is -1 standard deviation. Now, on a normal bell curve, a normal model, 68% of the data fits within those first two. So 68% cut in half is 34. So 34% on that section and 34% is on that left half. Okay. Plus or minus 2 standard deviations. So now we're going to go out another one and another one. And this is 2 standard deviations or -2 standard deviations, because it is possible to be on the negative side. Okay, so +1 standard deviation, +2 standard deviations away from the mean. I'm going to put a 0 there. When you're at the middle, that's your average. When you're at your mean, that is 0 standard deviations. 0 standard deviations. Because if these are measurements of standard deviations away from the mean and you're on the mean, you didn't go anywhere, so it's 0. Okay. Next one is going to be the third and the third. And I forgot on the second here, it's 95%. So 95% of the data fits into this middle section there. So if you do 94%, take away 34, and then cut it in half, you would get 13.5. Now you can check with your calculator right now. Add those 4 numbers up, 13.5, 34, 34, 13.5, and it will equal 95%. Okay, 97, let me list this here. This is 3 standard deviations, and this is -3 standard deviations away from the mean. This is 0 standard deviations. Okay. So 99.7% is right there. So if you do 99.7, take away all of those and cut them in half, you'd get 2.35. And again, you will have to know these numbers, but as long as you know the right half, the left half is exactly the same. 34, 34, so on and so on. All right, if you add all these numbers, you're going to be 99.30%. And what goes here, you cut that in half, and that would be 0.15. All right, so if you add all these numbers together, you would end up with 100%. All right, moving on. Traffic studies is an example number 1. Traffic studies have shown that the vehicle speed on a certain portion of a freeway, of course where there are no accidents or construction delays, follow a normal model with the average speed of 67 miles per hour and a standard deviation of 4 miles per hour. Okay, I'm going to write it here just as information with our notation. Remember that symbol there, the mu means the mean or the average, and it said the average was 67. And this notation there is standard deviation, and it told us the standard deviation is 4 or 4.0. Represent this information with a normal model. Indicate the speeds within 1, 2, and 3 standard deviations of the mean. You will use this graph to answer the next set of questions. All right. You'll be doing a lot of these on your worksheet today or in class, and so you want to get used to how to do this. And also it's going to come up on the test. Okay, so 1, 2, and 3 standard deviations. So here's my first. Here's my first. My middle one is 0 standard deviation. That middle one's always going to be the average, and the average is 67. So you can put a note there. That is going to be the mean, which is 0 standard deviations away from itself. Okay, 67, it's the mean. And then 1 standard deviation to the right and 1 standard deviation to the left. So you're going to add and subtract 1 standard deviation, the 4, from the 67. So you're going to do 67 plus 4 and 67 minus 4. So you're going to add and subtract 4 because that's what the standard deviation is. 67 plus 4 is 71. 67 minus 4 is 63. And again, you should eventually have these numbers memorized. That's right there is 68% of the data. Okay, next one, here's the second one, and we're going to keep plus or minusing 4 from now, 71 and 63. 71 plus 4 is 75. 63 minus 4 is 59. And again, these numbers are 13.5 coming from up here. And any normal bell curve like this is always going to be broken up this way. 34, 34, 13.5, 13.5. And then here it's going to be the 2.35. And again, those are numbers you will eventually want to have memorized, so start working on that ASAP. Okay, and again, we're going to add 4 and subtract 4. So this is 79 miles per hour, and this is 55 miles per hour. You add all these up, subtract from 100, cut in half. You end up with the last piece out here being 0.15 and 0.15. Okay, and now we are ready to use this model to answer the questions. Once you've made your model, answering the questions is actually pretty easy. What percent of the vehicles travel over 71 miles per hour? You just simply add those numbers up in your calculator. So you would do 13.5 plus 2.35 plus 0.15, and you end up with 16. And that's all you do. So 16% of people travel over 71 miles per hour. What percent of people travel between 63 and 75? 63 and 75. So you'd add 34 and 34. We already know that's 68. And then you do 68 plus 63 point, 68 plus 13.5. And that equals 81.5%. So 81.5% of the people travel between 63 to 75 miles per hour. All right, how about less than 67? So 67 is right in the middle. So if 67 is the average, and this is a normal distribution or normal bell curve, half of them are going to be to the left or less than. And you can add those numbers up, but I'm hoping it makes sense just from the curve that half are below and half are above. but let's just plug it into to check. 34 plus 13.5 plus 2.35 plus 0.15, and sure enough, we get the 50%. Okay, between 55 and 63, between 55 and 63, that's 15.85 when you add that together. Okay, less than 63 miles per hour. You can add those three, or you know that right there is 50. You could do 50 take away 34. I'm going to do that now. 50 take away 34 equals 16. I'm going to try that again. Where am I at? More than, oh, I'm sorry. I did read that wrong. I read it as less than, and they want more than. Okay, still as easy. All of this is 50, and then we add 34. 50 plus 34 equals 84. When I read it the first time, I accidentally read it as less than, and it is more than. More than 63, well, I know that half is 50 plus 34. Now, if you don't trust that, you can do 34 plus 34 plus 13.5 plus 2.35 plus 0.15, and you still get 84. So either way you think about it, it's going to be 84% of the people travel faster than 63 miles per hour. How about less than 59? Well, that's a pretty slow speed, so I wouldn't imagine very many, and you can tell here not very many people travel below 59 miles per hour. So you add those two together, 2.35 and 0.15, and you end up with 2.5%. Okay, the middle 95% of all vehicles travel between blank and blank. The middle 95%. 95% is 2 standard deviations, so that's right there. You can add those together, 34, 34, 13.5, and 13.5, and that should come out to be 95. So the middle 95 travel between what two speeds? 59 and 75. 59 and 75 miles per hour. Okay. You can hit pause and replay if you need to hear any of that again. I am going to move on to the back side. And now we're talking about z-scores. A z-score will tell you how far away you are from the mean. In terms of the standard deviation. One of the many useful aspects of the z-score is the comparison to different populations. So you want to compare this to that or that to this. You're comparing two different classes or two different students, whatever you may be comparing, you're comparing two different populations. The z-score works out nicely for that. And this here is the formula. And a reminder that lowercase sigma means standard deviation. The mu means the mean or the average. And that there is your score, the scores you're comparing. Whatever it is that you are comparing, this comparison piece, that's what the, I'm sorry, not the z, the x. Pointed at the wrong piece. X is the score, z is the z-score that we're looking for. Okay. So this is still z. X is the score that we are going to be comparing. All right. Tricia just found out what her score was from her AP Economics final. It was an 89%. Okay, I'm going to jump to her other class. Her AP Physics class was a 73%. Now, not looking at everything else, but just those two, you're like, oh, she did worse in this class. But how did she do in comparison to the rest of the class? So let's read that now. Okay, so she scored an 89%. The class average for the exam was 70%, and the standard deviation was 10.3. In her AP Physics class, she scored 73, and the class average was 68, which is lower, and the standard deviation was a lot lower, was not as spread out. What is Trisha's Z-score for her AP Economics class? Okay, in her Economics class, I'm going to put Z equals, and over here I'm just going to write down what everything else is. Okay, X is her score, the score she scored that we're comparing. She scored an 89. The mu is the average, or the mean. The class average is 70%. And sigma, that symbol there is the standard deviation, which was 10.3. And so you're going to have a fraction where there's X, which is 89, minus the mean, which is 70, over the standard deviation, which is 10.8. And you're simply going to plug that in your calculator. 89 minus 70 divided by 10.8 equals 1.76, and I typed that incorrectly, so I'm going to do that one more time. 89 take away 70 divided by 10.3, and that is a 10.3. My apologies. Okay, divided by 10.3 equals 1.84. So her Z-score for her AP Economics class is 1.84. Okay, Trisha's Z-score in her AP Physics class, let's figure out for AP Physics. Okay, for Physics, her score was a 73, so that's the X. The class average is 68, that's the mu. And the standard deviation is 1.8. So what is her Z-score here? Before I calculate the Z-score here, I just want to talk about what this means up here. When you have your bell curve, here's the middle, there's the class average. The class average was 89, nope, the class average was 70%. And then here's +1 standard deviation away, +2 standard deviations away, and +3 standard deviations away. And she has scored above the class average, so she would be on the positive side. If she had scored if she had scored below the class average, like say her score was a 60%, she would be on the negative side. But since she scored above, she's 1.84 standard deviations away from the mean. So here's 1, here's 2. So she's about there. She's 1.84 standard deviations above the class average. Okay, let's figure out for her AP Physics class. That's going to be 73 minus 68 divided by 1.8. 73 minus 68 divided by 1.8 equals 2.78. So in this class, here's the normal bell curve. Remember, the middle is always the average, and the average was 68, and this is 1 standard deviation away, this is +2, and this is +3. She scored 2.78 standard deviations above the class average. In terms of Z-scores, in which class did she perform better? Better in comparison to the class, she performed better here, because you can see she's 2.78 standard deviations above the class average, where here she was 1.84 standard deviations above the class average. So she did better in the AP Physics class. Because, and let's write down what I said earlier, her score was 2.85 standard deviations above the mean. AP Physics, because her score was 2.85 standard deviations above the mean. All right, we will finish the rest in class, and don't turn it in until we finish it in class. That is it for now.